So we're going to look again at another application of the scalar product. So what we're going to do here is put in a couple of vector lines. I'm going to try to do this in a slightly different way. Sorry, a couple of lines using their vector formula. So we're going to have 4, negative 35, 5, 6, 11, 9. So that's the first line through running through there. And the second one is 2, 1, 3, 4, negative 1, 1. So that's 2 lines given their vector form. And you will see that they are skew. They do not cross. At some point, though, they get their closest that they're going to get together. Now, this can automatically work this out, which, fine. There we go. And it adds this third beam between them. Now, as you might realize from our previous work, this green extra section here is the shortest distance, and it has a particular arrangement with these 2 lines. As you can see from this direction, this is perpendicular to the red, and it's also, if we look over here, perpendicular to the purple. So there is exactly one path that's perpendicular to both lines that goes through them. So if I could find the coordinates of this point and this point, I can then use Pythagoras to work out what that distance is. Okay, and that's what we're going to try and do today. So I'm going to take that off. Hopefully, I'll go back a few steps, and then we'll go through the algebra to work out what it ought to be. And then we'll see if the coordinates I get match that projection. So I've got the lines already written here. We're going to characterize point P, which is on R1, much like we did last time. 4 plus 6 lambda, negative 35 plus 11 lambda, 5 plus 9 lambda. I'm going to characterize point Q as being on R1, 2 plus 4 mu, 1 take mu, 3 plus mu. So those are 2 points PQ. Now, we want to find the vector between them, which was that green bar on the diagram. So the vector between them is going to be P take Q, or Q take P. If I do P take Q, it's going to be QP that I'm going to find. So P take Q is 4 take 2 is 2 plus 6 lambda take 4 mu. Negative 35 take 1 is negative 36 plus 11 lambda plus mu. And 5 take 3 is 2 plus 9 lambda plus mu. That's a pretty gnarly looking vector, but it is just a vector. So this vector, we want to be perpendicular to both lines. So this dotted with that needs to come out as 0, and this dotted with that needs to come out as 0. Luckily, that's 2 conditions, and there's 2 variables, so that should exactly match out. So if we start with 6, 11, 9, dotted with 2, 6 lambda, 4 mu, negative 36 plus 11 lambda. A lot of writing. With that, we get 6 lots of that thing, which is 12 plus 36 lambda plus 24 mu, plus 11 lots of this thing. So that's take 396 plus 121 lambda plus 11 mu, and 9 lots of that. So plus 18 plus 81 lambda plus 81 lambda, sorry, plus 9 mu. And that all simplifies to be 238 lambdas, take 22 mu's, take 366. And because that's set equal to 0, we've got an equation. Because we want it to be 0 because of perpendicularity and the dot product giving us that property. We can do the same thing with this. 4, negative 1, 1, dotted with 2, this here should be negative. This here should be negative. This here should be negative. No mu's take away a mu is negative mu. I think this 22, they will still be correct. 24 plus 11 take 9. There's a negative there, which we went missing as well. Terribly sorry, folks. Got to keep track of your signs. Problem with there being lots of writing, you can make mistakes. So multiplying that out, we get a horrible long string like this, which ends up simplifying down to 46 plus 22 lambda take 18 mu. So these two equations can be solved simultaneously. I actually use the equation solver to do that on the calculator, which you should all have for your A-level. So to do that, these need to be in a form we can use. So it should be, this one will be rearranged to 238 lambda take 22 mu is 366. And this one should be 22 lambda take 18 mu equals negative 46. And then when we put that through our simultaneous equation solver, or if you want to, you can crack through the algebra yourself. But you know, that's entirely optional. You can see that's probably light enough. We get 238 take 22, 366, 22 take 18, take 46, and we get that lambda is 2 and that mu is 5. So we can use those values to work out what P and Q are. And in fact, yeah, we do a P and Q just so we can show you where they fit on the graph. So using these values over here, we get that P is 4 plus 6 lots of 2, negative 35 plus 11 lots of 2, 5 plus 9 lots of 2, which is 16, negative 13, 23. We get that Q is 2 plus 4 lots of 5, 1 take 5, 3 plus 5, which is 22, negative 4, 8. And we get that P that Q to P is 6, no, negative 6, negative 9, 15, which is the difference between these two values, or we could use this form here. So the size of QP, just a bit of Pythagoras again, square root of 36, 81, and 225, which comes out to be exactly 3 root 38, which is roughly 18.5. So if we head back to the graphs, we'll see if those 2 points are indeed the correct points. So we should have that up on the screen now. And again, if we select them, do shortest distance, it's given us these 2 points here, which, if I'm correct, should be the P and Q that I worked out a second ago. So we'll stick the coordinates in: 16, negative 13, 23. Yep, that's come up on this end. So hopefully this will be Q. Stick a new coordinate in: 22, negative 4, 8. And there it is there. So we've got the right values. So hopefully the results box, if I can see it, has a distance that we can show you of 18.49, which is pretty close to my 18.5, which is almost certainly just a rounding that I did. So I hope that makes some kind of sense. I hope you can see the value of the dot product. And as with everything else we've done with dot product, it doesn't matter how many dimensions you're in. This is just as true in 2D as it is in 35D. Assuming, of course, skew lines exist in that dimension. So maybe 2D is not the best example. But anything 3 and up, you can easily have lines that do not intersect. And by using this perpendicularity, you can limit yourself to find their shortest distance. So I hope that makes some kind of sense. And I'll see you next time.